Well, g'day guys, how you going? Mr. Hewitson here. Feeling a bit puffed out. I've just been for a run up here at my local, and I just got to thinking about evolution. You've been learning this week all about how things change over time, right? Hopefully you've been doing a bit of your homework, yeah? And following Mr. Jopoulou and my work for you. And what I thought was, imagine if you had a wrong idea of evolution. Like, things change over time, right? So that could include people, right? Now imagine if I go for my run today, and look, I did pretty well. I ran 5 kilometers. My fitness is increasing. That's got to be good. So let's say I might be starting to look like this bloke, right? By running, I've actually put on some more fitness, and that's made changes in my body. Now, what if I had a view of evolution that said, if I work hard and get a change in my body during my lifetime, well then that's stored in me somehow, and I can pass on super fitness and really fast running efficiency to my kids. Well, that's a nice idea. We'd like to believe that. Did you know that in the history of evolution theories, someone had an idea exactly like that? His name was Jean-Baptiste Lamarck. And Lamarck had that exact idea. Darwin's ideas were getting around. He hadn't published yet, but it was starting to come out. His idea about natural selection you've been learning about, and Lamarck had his own idea, which looked a bit like this. Yeah, his idea was actually a lot like the crazy idea I had about passing my running fitness to my kids. His idea, he expressed it with an example of giraffes and says that, well, eventually, way back, if you go far enough, you can find ancient giraffes, ancestral ones, like in the picture here, and they stretch their necks to try and get up to high branches on savanna trees. It's grasslands in Africa where they live, and they stretched and stretched. And what happened because of all that stretching, somehow their body stored that change somehow, and then when they mated with another giraffe and they had offspring, as you can see along the arrows as you head right, those offspring were slightly longer. The necks were stretched. The need for change somehow got stored in their genes or whatever, just from stretching and having a survival need. And then, because those giraffes stretched, the children that they had when they mated with a giraffe was even more exaggerated, and they had an even longer stretched neck. Are you the only one who finds that a little bit strange? No, you're not. I find that a little bit strange. And Lamarck was trying to actually put up his own alternative to explain how species would have changed over time. But as we know, the man who's developed our great theory that stood the test of time is not Lamarck. His ideas were discounted because of the things that Charles Darwin found. And so Charles Darwin's theory, the one you learnt about week before last, is the one that stays behind. And that, just to run over that again. So now take a look at the way Darwin's theory explains it. His theory is natural selection. And so there might be a whole mix of giraffe animals that were ancestors, and they had different shaped necks, different lengths, right? And they all existed together. The evidence of fossils tends to support this idea that there is actually great variation among species, not one sort of species like Lamarck talked about, a short-necked giraffe. And the idea here is that with competition, they're just competing for food. The guys with the longer necks went out over the short neck guys. And so eventually, with the competition for food, long guys went out. They're just far more powerful in the population. They get more food. They make it to mating age more regularly. And so eventually, the long neck ones are the ones that mate and live on. And it happens over many hundreds of thousands of years, sometimes even 1 million years, that the slow death of the short neck will happen and the triumph of the long neck. And Darwin called this a competition. He said nature is red and raw in tooth and claw. It's a horrible competition, and if your luck turns and you happen to get the special trait that suits you up well, like a long neck in the giraffes, then you win. But luck turns on you if you're a short neck. Your variety will be gone soon from the population. So who do we believe? This guy, Lamarck, pass on the traits? Or did people go with this guy for all his wonderful, well-published work with evidence behind it? Yes, it's Charles Darwin. We did go with his theory, and that's actually why you're learning about it today, this term, in distance learning on this Year 10 topic, Life on Earth. His theory prevailed mainly because it had a really solid base of evidence behind it. The last week in science, you've been coming over and having a look at some of these evidences. The main sort of primary evidence for evolution that backs up Darwin's original idea that there's varieties and then there's a winning variety over other losing ones, and they slowly compete. This idea, the big supportive evidence for it is fossils, right? And so Mr. Jopoulou put something up for you in some of the work to examine what fossils are like and what they show. And they tend to show Darwin's view of how the giraffe necks got long, not Lamarck's view. They back Darwin's view that there was little varieties that were all living together. They were coexisting, and it backs up this idea of competition, or as he called it, natural selection. In the competition between varieties, something will be favoured by natural evolution. And what were those main things we learned about fossils? Well, they're here on the fossil summary slide. That was on the week's PowerPoint. Earth is very old, about 4.5 billion years old, that's right, 460 million that is. Life forms changed over that time, so there's been, species aren't fixed, they change, just like the finches we talked about in the last video. And also, life forms evolve in a special order. That is, there's this slow development from one particular feature, and over time, many long generations of time, over many babies, and then the babies' babies, and then the grandbabies of those babies, there'll be slow change across those generations. And actually, that life on Earth, it's actually gone over millions of years. I mean, look at us, the human beings, and even wonderful human beings like me and like you, great specimens we are. We have really only had our evolution take place over less than 100,000 years. And think about that compared to 460 million years. Our little timeline is only a blip on the big timeline, yeah. If there was a roll of toilet paper, a massive long roll of toilet paper, and you rolled it out, like across my backyard there, I rolled it out, it would go past that brick wall and over, probably another 2 yards over. And if you took the first slice of toilet paper and you ripped a small piece off one edge of that to piece, that would be the amount of time we've been around compared to the history of time way over there 4.6 billion years ago. But as we've been saying, evolution relies on evidence, and there is evidence that Darwin's theory was spot on, particularly things like what we call transitional fossils. What's that? Well, this is a good example of a transitional fossil. This is Archaeopteryx. You had a look and answered some questions on him. If you have a look, just zooming in a little bit, transitional fossils are sort of stopgap fossils. You could say they're the ones that stick in between one clear form and then another form that's more recent. And the idea is these organisms are long gone. The only way they live, so to speak, is in their fossil remains. And Archaeopteryx was some kind of unusual dinosaur bird. It had unusual things. It had avian dinosaur features. It had the reptilian kind of claws. It had a wing kind of shape with its arm over here on both sides, and a symmetrical shape with wings. It had a sort of a long tail, which is a bit more like reptilian. And so it was this real crossover with birds and dinosaurs. And it was the famous one that Darwin, was able to point to, and great support came for Darwin's theory with the discovery of Archaeopteryx's fossil, because we're basically now saying this fossil stood in the middle, and it proves that there's this slow march of time going forwards. Species are changing, and the fossils paint the picture. Well, hopefully you finished off the week with those questions on, there's a little article as part of the notebook which I provided you, or maybe you used the page references, or maybe you're using a booklet, doesn't matter, as long as you get your work to me. But in that notebook for this week, we put up The Story of Life, which is a small kind of textbook article about that long, slow developing story of species evolving and changing from a relatively smaller number of plants, invertebrates, vertebrate animals, mammals, etc., to branch out to this huge, large number the further you go through time. So it's a story told over time. Pretty amazing, right? And hopefully you also took time to answer the questions on The Story of Life. And I left you space in the class notebook on Microsoft Teams. All you do is edit that notebook, and I've left a space for each of those 8 questions. Could anything be easier? Anyway, we're previewing up to week 4, and you're going to find all this thing about evolution. As you finish that work, make sure you finish it. It's very important to get it in your mind, because you've got to get these things in the right sequence in your mind. We've learned a bit about how fossils really back up the story of evolution and show the story of life advancing. Guess what? There's a ton more evidence that backs up Darwin's view about varieties of variety of species living together, and then a competition and one being selected. There's actually evidence for that picture from a number of different sources. In science, we call that lines of evidence. So we're going to look at a bunch of those this coming week. So watch for tomorrow. Tomorrow, Miss Georgopoulou's training video will come up on Google Classroom. Make sure you look at it. But hey, keep on working. And guys, remember, even though your story is one small lifetime in the middle of only a 100,000 year blip in history, you are very important, and we care about how you're going. So good luck, and don't forget, ask your teacher questions if you need any help. And goodbye.